Alright, so we're going to look at transforming functions, and this is actually the parent quadratic function. Y is equal to x squared, also written in function notation here as f of x is equal to x squared. So let's look at some of the things we're allowed to do. We can, actually let's take a look at the graph. Here I have y equals x squared. I also have it solve for y. These ones are the coefficients of y and x. I divided both sides here by 1, so it's in y equals form. And we're going to see what happens when we multiply x by a number. So if we multiply x by a number, let's say 2, oops, that's not multiplying it. If we multiply x by 2, you'll notice the graph appears to be shrinking, but by how much? If we look at this point here, it should become a bit more clear. And this is 1, 1. But if I multiply this by 2, it went from that point at 1 here went to a half 1. So this actually became smaller by an exact factor of a half. If you look, this is at 1, 4, but if I move this back, it should be at 2, 4. Alright, so by multiplying it by a value, it actually compresses the graph by a factor of that value. Alright, so that would be important to write down in your notes. So let me type that in here. When multiplying x by a value of, we'll call by a value, the graph will compress by, move this up so you can see a little better, that factor. Meaning all of its values will be divided by that amount. So for instance, f of 5x multiplying the x value will actually be, that's 5x squared, or 25x squared, will actually be a compressed graph of this one. So that's compressed. Alright, so that's the same thing as saying y is equal to 5x squared, which is equal to 25x squared. Let's look at what happens when we multiply y by that amount. So if we multiply y, you'll notice the graph actually stretches. Sorry, let me fix that. Alright, so when you multiply the y value, it actually it stretches and compresses. Oh, I forgot to mention, if this value is negative, it actually flips the graph over. So if this, actually in this particular case, the y value, the multiple for x doesn't flip the graph over because we're squaring it. So 2.4 squared is a positive number, so it didn't change anything. So by multiplying y, it stretches the y values. Okay, so let's maybe put that in our notes. What did it do exactly? It took, let's multiply it by 2 so it's a bit more clear. So it compressed the y values. So this was at 1, now it's at a half. Alright? So when we multiplied x by a value, the graph compressed by that factor in the x direction. Whereas if we were to multiply y by a value, the graph compressed by a factor, by that factor, the y direction. Alright, so let's take a look at what that would look like. We multiply. I'm only going to erase this for the sake of space, so you can always rewind and copy that. So let's say that was 2 times f of x equals x squared. That would actually simplify to be f of x is equal to x squared over 2. Alright, so it will be half the size in the y values. That would be, over here, that would be 2y is equal to x squared, which again simplifies to y is equal to x squared over 2, which again will compress that value. Alright, so let's take a look what happens when we add values. If we have f of x equals x squared, and we change that to f of x plus 2, we'll actually get an interesting little shift in the graph here. This will actually become x plus 2 squared. Alright, so if we have y equals x squared, that would become y is equal to x plus 2 squared. Alright, so let's take a look at what happens to the actual graph. If we add a value to x, 2 for instance, it actually shifts the graph 2 units to the left. If we add 5, it shifts 5 units to the left. If we add negative 5, it actually shifts 5 units to the right. Alright, regardless of what these multiples are. Oh wait, that vertical stretch actually shifts it after. So that shifts it 5 units to the right, but the multiple actually stretch it. These compressions will actually be based. These compressions are actually based on the 0 values. Let me put that back. Alright, so for our notes, by adding a value to x, the graph will shift x, well, that many units to the left. Unless, of course, that value is negative, in which case it will shift that many to the right. Similarly, by adding a value to y, the graph will shift that many units down, unless of course it's negative, in which case it will shift upwards. So let's take a look at that. And so move that back. Well, it doesn't really matter where this is. But if I add a value here, let me actually remove that. 0, 1. If I actually add 3, it actually shifts down 3 units. If I were to add or subtract 2 units, it would move up 2 units. Right? Let's go back to the slide for a moment and take a look at an example. Okay, so everyone should have that in their notes. Let's erase this. Alright, so let's say we had a function f of x is equal to 3x squared minus 6x plus 2. And we transform this function. Now we have options. We can add a value to x, so add 2. And what that will do is that will shift the graph 2 units to the left. We can add a value to y. or subtract the value from y. And this will shift it upwards. In fact, let's take a look at that. Maybe this isn't the best example. Let's use x squared. Well, f of x equals x squared. So, if we have f of, let's say we multiply this by 3, add 2, and then to y, we will divide that by 5, or multiply it by 5, and subtract 3. Because again, f is this. So this graph will do a couple things. This would be the same thing as saying, so we've added a value to x, subtracted a value from y, multiplied x by a number, and multiplied y by a number. So that would simplify to be f of x, well, that would actually be 3x plus 2 squared, which is 9x squared, 6x times 2 would be 12x plus 12x plus 4. So that's this. And that would become f of 3x plus 2 equals, first we'll subtract 3 from both sides, 9x squared plus 12x plus 1 over 5. So that would be the new function in this case, and it would have done a couple of things. Firstly, it would have shifted left 2 units, right up 3 units, then it would compress horizontally or along the x-axis by a third. Then it would compress vertically by a fifth. In that order. The shifts will happen in that order. So let's take a look at the other graph. So let's take a look as we make small adjustments. So I'm going to set the other graph back to normal, y equals x squared. Alright, so it's going to shift 3 units, it was 2 units to the left. We then subtracted 3, so it shifted up 3 units. Then it compressed by a factor of 3 in the x direction. And then we actually compress by a factor of 5 in the y direction. So it's coming in a downward form here. So this graph is actually the same as the equation as I wrote on the other slide. So to summarize, by adding a value to x we shift left, by adding a value to y we shift down, by multiplying x by a value we compress in the horizontal direction, and by multiplying y we compress in the vertical direction.